Hi, my name is Dr. Emily Schaller, and I'm here at NASA's Wallops Flight Facility on the eastern shore of Virginia. We're here because NASA is using airplanes to study hurricanes. The mission is called HS-3, which stands for the Hurricane and Severe Storm Sentinel. What's a Severe Storm Sentinel? It's actually a remotely controlled airplane called the Global Hawk Unmanned Aerial Vehicle, or UAV. Pilots fly the plane from a cockpit on the ground. NASA is using these Global Hawks to study hurricanes in the Atlantic Ocean by flying over and around them. The Global Hawk can fly for very long periods of time at very high altitudes. It can fly almost twice as high as a commercial jet, and it can fly for over 24 hours without stopping. That's why scientists are using the Global Hawk for the HS-3 mission, so they can continuously study storms as they develop. Forecasters have a pretty good idea of where these storms go, but what they want to know is, will they grow? We spoke with NASA mission scientists about how the Global Hawk will help improve their understanding of hurricane formation and growth, and why it's so important for us to learn more about hurricanes.
The Hurricane and Severe Storm Sentinel has a goal to try to better understand the processes that control the intensity of storms. The ability to predict the intensity is very important because it impacts people in the coastal zones who, if they're anticipating, say, a tropical storm, a Category 1 storm, and they end up getting a Category 3 storm, it makes a big difference in terms of their ability to prepare and deal with the storm consequences.
And this is really important because the category of a hurricane is the intensity of the winds associated with a hurricane. So a Category 5 hurricane is much more destructive than a Category 1. So being able to predict the difference between just a tropical storm, a Category 1, up to a Category 5 is really, really crucial to saving lives and lessening damage and so forth, particularly saving lives.
The benefit of HS-3 compared to any other hurricane mission is the fact that we have these planes able to fly upwards of 24 hours, and being able to monitor a storm for that long period of time and getting constant data, we can actually catch changes in the storm.
We will use two Global Hawks. One Global Hawk flies over vast areas around a hurricane. It measures the environment that a hurricane is embedded in. And then the second Global Hawk, instead of sampling the vast area, it goes right in to look at the eye and the eye wall and the inner core processes of a hurricane.
The Global Hawk unmanned aerial vehicles flown by NASA were originally built for the military and used for flight testing at Edwards Air Force Base in California. When the Air Force was done testing these models, they were transferred to NASA, which turned the planes into airborne laboratories to study the Earth. NASA flew its first science mission with the Global Hawk in 2010.
The Global Hawks are really a new aircraft for doing hurricane studies. Manned aircraft typically fly for, say, 8 to 10 hours when they do a research flight. Of that 8 to 10 hours, you may have 4 hours or more just getting to and from the storm, so that in a typical flight, you only get 4 to 6 hours actually sampling within the storm. With the Global Hawk, we can get 3 times, sometimes even 4 times as much as you can get with manned aircraft.
Now this plane can fly to 65,000 feet. It can fly 13 miles up. It can also fly for nearly 30 hours. So this plane can take off here from Virginia, on the coastline of Virginia, close to where hurricanes form. It can fly all the way to Africa. It can spend about 10 hours on the coastline of Africa and then fly all the way back. There is no plane that can do that in the NASA vehicles that we have.
Because the Global Hawk can fly so high for so long, scientists can study larger areas of the Earth for longer periods of time, in places where planes with pilots on board may not be able to reach. We spoke with pilot Phil Hall about the Global Hawk and what it's like to fly the plane without actually being inside it.
So the two Global Hawks that were flying for HS-3, Air Vehicle 6 and Air Vehicle 1, From a pilot perspective, it's a very different aircraft. We don't have any rudder pedals or a control yoke. We actually use a mouse and keyboard. We actually have a control room on the ground. We have 2 of them now. We have one at Edwards Air Force Base in California, and we have one here at Wallops Flight Facility in Virginia. So it's basically like a trailer. It's been specially designed for Global Hawk. It's full of computer systems that can talk to the aircraft. So we can connect to the internet, and all these satellite products of Lightning, the storm from satellite images, we're able to download that almost real time and use that to actually navigate the storm. For the first part of the mission, we actually fly the aircraft from Wallops. And once we get about 2 or 3 hours into our flight, we actually transfer control of the airplane back to Edwards Air Force Base, NASA Dryden Flight Research Center. It's very different from any other kind of aviation operation in that we have pilots on both coasts, and we can actually transfer control of the aircraft during the flight to the other pilots. And when you have these long missions, like 26 or 27 hours, one person can't sit there for the entire flight. So we actually have 3 or 4 shifts of people that come and go to man this aircraft.
Now, pilots know how to fly planes and they can tell the plane where to go, but how does a pilot actually know where to go? You have to have scientific information. Now, the scientists sit in a separate trailer. We have computers sitting in front of us. We bring in satellite information. We bring in forecast information. And because weather can change so fast, they can collect that information, interpret it, and then relay it to the pilots and say, well, instead of going over to this point, why don't you go over to this point over here, which is where we think the eye has relocated. So it's a great team between the scientists and the pilots to actually get the most information you can out of a flight.
How can you become involved in our mission? You can follow the plane too, just like the pilots and scientists do, by participating in live chats, where you can get live updates on where the plane is flying right from your own classroom.
You can definitely be a part of our mission by actually being able to look at the same screen we're looking at. I'm looking at where the plane is flying with respect to the storm, and you have access to the same data I get to look at. You have access to see the plane's altitude, you can see the wind speeds, you can see the wind direction, and you can chat live with pilots, with forecasters, mission scientists, and we're looking at the same thing you are, and that's just really exciting to know that you can ask us any question at any time, and we are right there looking at the same thing.
To learn more about our mission, visit nasa.gov/HS3. See you next time on NASA Airborne.